We've now come a long way in the animal kingdom if you've been with us since the beginning. Now we finally get to move into our Deuterostomes. Still bilateral symmetry, still 3 tissue layers. Keep in mind what those things mean. But now we have a new form of development. For this first group, the Echinoderms, you are unlikely to see the level of complexity. I understand that. But keep in mind, you are a chordate. This last group we'll talk about after a while. The Echinoderm is your closest relative on this tree. In Echinoderms, we include primarily the sea stars or the starfish. Okay? And what we look at in this development are also sea cucumbers, sea urchins, those kinds of organisms. They're actually, this is one of our smaller phyla with only about 7,000 identified species, but they are still a giant group to contend with as far as their diversity goes. Now, when we look at them, we can either look at them as being sessile, that we've talked about before, meaning that they kind of stay in one place, right? Versus extremely slow moving. These are not racers. These are organisms that are going to move deliberately if they move around at all. They're all marine species. This is actually an interesting one. So we actually think about the Echinoderms as being a fairly old phyla because they are all still marine species and have not moved onto land or into fresh waters. They are radially symmetrical at some points, but we classify them as bilateral in their symmetry because symmetry is all determined during development. And I will show you that these organisms in their larval stage are bilateral. So what we usually look for is what we call variations in symmetry or alternating symmetry throughout their life cycle. In our Deuterostomes, we've talked before, anus forms first. These are kind of the highlights. Starfish, I think you're probably familiar with, but the interesting thing about starfish is these are one of the more mobile of the Echinoderms, meaning they move around more. But they still don't move very fast, right? They're pretty slow moving. But they move through a hydrostatic system where they actually are going to use their tube feet and suction to actually allow them to move around. It's pretty fun. But my favorite aspect of these tube feet is that in our starfish, the mouth is actually on the bottom. Their anus is on the top when you look at them. So when they eat, they're actually wrapping their feet around. These tube feet wrap around and grab onto the clam like here. And their mouth is on their underside. This is the underside of the starfish. So the mouth is actually throwing up the stomach inside this clam and is going to digest the clam inside its own shell. And then the stomach will roll back up inside the starfish with all the clam inside. Don't be grossed out. That's fun, okay? So the interesting thing about these tube feet, if you've ever tried to open a clam that was still alive, these tube feet have a lot of work ahead of them, right? So this starfish will actually pull a little bit on the clam, put tension on it, and essentially wait for the clam to get tired. When the clam gets a little tired, the starfish will pull a little bit more, and eventually the clam just kind of gives up. And the starfish has dinner. This is a sea urchin while it's alive. Many of you have seen them dried out with spines, very prickly spines like a porcupine. But in their live stage, they're actually quite beautiful in their dimensions and how they move around. Again, with some tube feet, so they can move around, but it's a ball with tube feet, right? So this is kind of an odd movement, and they move very slowly. So when we look at this phylum, as I mentioned, they start out bilateral during development. And many of them transition to radial symmetry or pentaradial symmetry, so our 5-point symmetry, like our starfish, right? kind of a starfish. Okay. So here it is in development. Here's our egg and sperm going through this developmental process. And you see right here, remember, bilateral means I can split this thing in half and it has 2 equal sides. Well, there it sits, right? Now, I agree, as they grow up and go into adult stage, this looks much more radial to me, right? As opposed to the bilateral in the larval stage. But keep in mind, we identify these organisms on our tree based on their developmental larval stage, and that in this case is bilateral. So if you really like the idea of starfish being radial or pentaradial, that's fine. But keep in mind that you need to think about the fact that in development they're bilateral and they actually move into this more radial form as adults. Not all of them are radial. Finding the symmetry in this mess here would actually be kind of difficult, right?